Good morning, everyone, and welcome to today's SyteLEAN webinar. SyteLEAN is a lean and responsive inventory management system for SyteLEAN and CloudSuite Industrial. SyteLEAN calculates optimum inventory levels based on actual sales and usage, allowing manufacturers to automatically manage inventory for changes in demand and product mix using lean concepts that are much easier to deploy and manage than MRP. Presenting SyteLEAN today is JD Goodrich, Senior Manufacturing Consultant at DRI. JD has more than 20 years of experience with SyteLEAN and CloudSuite ERP implementations. He is a lean manufacturing leader and facilitator, and JD has held multiple positions in the industry, including that of Director of Manufacturing for an electronics manufacturer. Without further ado, JD, take it away.
Thank you, Emily. Good morning, everyone. I'm going to do my best not to read these slides to you, but rather talk to you while you read them. This is going to be the agenda. I'm going to go through our simulator, kind of what a SyteLEAN item looks like and how some of our core processes operate, how SyteLEAN can be used to replenish the inventory in one-piece flow lines or continuous flow lines, some of the supply chain stuff that we do, and some miscellaneous features related to multi-warehouse and purchasing processing. I'll try to keep to the 45 minutes so we have plenty of time to answer questions. So fundamentally, at the heart of most lean implementations, one of the tools in the lean toolkit is a pull system, and typically companies are looking for a way to switch from the standard push signal that you see from MRP to a pull system. Critical to this switch is the calculation of the Kanbans of the inventory buffer, and we sometimes they're mechanical, sometimes they're in this case electronic. There's a lot of different ways people implement Kanbans. This is an electronic Kanban, an electronic pull system, and SyteLEAN's focused on making sure that those inventory buffers are easy to calculate and sync up to your current environment. With any pull system, the signal to replenish, it's going to be driven by consumption, right? It can also be used as an internal Kanban system, and let me explain what I meant there. We replenish the entire system, all of your non-dedicated warehouses, with SyteLEAN through purchasing or manufacturing the same way MRP or APS does. Unlike MRP or APS, we also provide a tool to replenish specific inventory locations, to study those locations for their usage, their deviation, and calculate buffers at point of use locations. We're integrated with the planning engine in that we use the same exception messaging, and we use the same material planner workbench and planned order concept that APS and MRP do. SyteLEAN also provides another layer of inventory management because of the fact that we can status the inventory using the SyteLEAN tools. All of you probably know that MRP is completely quiet about an item unless you need to buy more or cancel a PO or move a PO around. It doesn't really ever tell you if you have too many or too few. And with SyteLEAN, we have that additional information. I've got a couple of core procedures that we use. I've got screenshots of those coming up in just a minute, but they do the heavy lifting for you on the math side. The mine your material transactions, your customer order shipments, looking both ahead and behind to come up with an average daily usage, which is, of course, what your buffers or your Kanban should be based on. We have a service level based variable stock, a variable safety stock, and what that means is that you define the service level. Most of you are familiar with that industry standard term, service level. The higher the service level, the higher the safety stock will be. SyteLEAN lets you establish that globally and at the item level. Our trigger point is where we signal that you need replenishment, and because of that, and because of the method we've adopted to fill that buffer back up in the same way that an empty tote would be filled back up, we're able to predict your average inventory level. And that's a pretty cool tool. You can tell from a change that you might make to the service level what direct impact that would have on the average inventory level. I've already talked a little bit about the inventory and supply chain status features, and we also do in a couple of different ways show you how many days on hand you have, not the days supplied field from CloudSuite, but rather how long the inventory will last you based on this average daily consumption. I'm going to start with our simulator because it's what we do. It's how we start when we go through an implementation. The simulator allows us to form a collection in CloudSuite of every item in your database with the static data, like how many you have on order, but it also what your average daily usage is, what your standard deviation is, and these individual inventory statuses. You can see from this slide that I've did a quick data view of the SyteLEAN simulator data and organized it by on-hand status and planner code. I have some 23 items that are in excess condition, and the planner and 11 items that are in an expedite condition. And I'm sure most of you are familiar with our data view kind of super grid process, if you will. Obviously, this form is a standard form in SyteLEAN. It has all those same standard features. I've exported the SyteLEAN data from the simulator data form to Excel to highlight some of the other fields, just make it a little bit easier to see. In particular, I've highlighted a tool that we use when we're deciding which items would be good fits for SyteLEAN. When I see an item with a very large standard deviation when measured against its average daily usage, that's a signal that maybe the consumption of that item is super lumpy. We don't use it frequently. We used a bunch of them, so I get an average daily usage, but we don't use them continuously, and maybe that's not a good item for a pull system. I can also use my simulator to take a look at these other features, right? How a service level would impact the safety stock, and then for the remote warehouses, well, what should the safety stock be? So that's kind of information is a little tough to get in the standard CloudSuite package. Other than the forecasting application, I'm not aware of another tool that automatically calculates your safety stocks for you. Move to the next slide. This is the final look at the spreadsheet that's created when the simulator runs. And over on the far right of the simulator, we bucket the usage data into 13 periods looking behind and 13 periods looking ahead. That column AT in the spreadsheet is showing that's today's date, back when I captured this information. And you can see both what the usage has been for the item and what the planned usage coming from the APS and MRP tables are. This is again a useful tool to help us figure out which items would lend themselves towards a pull system rather than a push system. Once we've narrowed the list of all your items down to those that might be a good fit for the SyteLEAN family, there's two core procedures that we utilize. The buffer data utility does most of the heavy lifting on the calculation side for those items that belong to the SyteLEAN family. It typically sits in the background queue on a monthly basis, or maybe as frequently as weekly, but seldom more frequently than that. And then the buffer status utility, think of it as the MRP planning or APS planning run. It's a post processor to MRP or APS, and it comes along and calculates replenishment advice for the SyteLEAN family. It in effect replaces the MRP or APS new order advice. Obviously, we leave any exception messaging from APS and MRP available to the user. The SyteLEAN item form is where you can see this data. This is similar to the item form in that it's where you can set some of the SyteLEAN item fields, basically the lead time factor and the service level, both of which are used in the calculation of the safety stock. Those are at your those are pretty much at your disposal. Pointed out a couple of things on this form. Whenever I open this, I can see when the last time my usage was calculated. I can see whether there's been any spikes for this item, and that's a big deal. For those of you that are familiar with the pull system, you know that an upcoming spike can be a problem in that it'll drain the buffer, or worse, you can't even begin to drain the buffer because it's a ship complete order maybe, and you want to begin to move materials onto a container, and you need to have a good way to see that spike and take whatever actions necessary to compensate for it. Excuse me. On this form, we're seeing the trigger point, the strategic buffer, which is the average inventory, the current on hand, and then down in the bottom of the form, you get that sense of whether the inventory is too high or too low, and how many supply days of inventory you have, both from an on-hand perspective and your total supply. Obviously, the difference between those two being on-hand is nettable inventory in the non-dedicated warehouses, and supply would also include any open purchase orders or manufacturing orders. The buffer status utility follows a pretty simple algorithm, and I won't spend enough go through this in detail, but essentially what we're doing is making the decision whether the supply chain needs to be replenished or not. And if so, a planned order is created with a date equal to the lead time of the item, today's date plus the lead time, or in the case of an expedite, we predict the date you'll run out and calculate the due date of the PLN based on that run out date. It's a pretty simple. Sometime I'd like to compare this algorithm to the APS algorithm so that we can see which one of those two is easier to understand. Internally, I'm going to switch to that internal Kanban now. We're doing the same thing internally that we do externally. We can configure the system to incorporate both the historical usage and the predicted usage. Obviously, you don't have predicted usage for a location, so it's limited to historical, but system-wide, we can also consider future demand. And the most important thing is it helps prevent that overproduction and overprocurement that is the number one waste in your lean in your lean thinking, right? Most of you already know that. It's super difficult to stop the enthusiasm of your employees to build more and buy more, and SyteLEAN with a pull methodology absolutely puts a lid on that problem. The point of use Kanbans consist of basically three simple steps. First, you define a buffer for the replenishment. And you can see that up there at the very top of this form. In this Kanban management tool, I've said where I want to keep these parts and how many of them I want to keep. Then the SyteLEAN Kanban replenishment utility wakes up every hour, surveys the existing locations, looking for any place where there's been consumption driving the inventory below the trigger point, and signals a new replenishment requirement in this Kanban transaction form. This is number 3. Your stockroom folks will come up, print these pick tickets, carry the materials to the floor, and then optionally scan that little Kanban ID to cause the system to do the inventory move. Here's an example of that Kanban posting where I've scanned that simple little barcode in the upper right-hand corner of the Kanban card that I printed from the replenishment screen. And when I scan that, it pre-populates the move transaction with the from and the quantity and the to, and all I have to do is post it. Alternately, this could just be a move transaction, which is all we do behind the scenes. All right. I think I'm a little bit ahead of schedule. That's good. That'll leave us with time to get through as many questions as we have. The couple of different reports. This SyteLEAN spike demand report, think of that kind of as the item bottleneck report in APS, or the order action report in MRP. If you're a CloudSuite user, you know that most of the data you need in SyteLEAN is readily accessible through views and forms, and we don't go outside of the system with hard reports so much anymore. In the SyteLEAN item form, I can see the spikes, but if you want a printed copy of any upcoming spikes, we've got a report to do that. And then the supplier forecasting is a pretty cool process. Today, it's pretty difficult to show your suppliers what the planning data says will be upcoming for this item. You'd have to create your own data view and link the vendors to the items, etc. And that's not extremely difficult to do, but we do that for you with this report. This gives me the ability to place this report in the background and have it created for me on a weekly basis and sent out to my suppliers, so they'll see what I'm seeing from a planning perspective. That's useful to them because we don't do blanket orders anymore when we're in a pull system. We have we want to make sure that we only release when we've had consumption. And any of you that have used blanket orders in the past know how dangerous they get to be. The inventory begins to pile up on us, or we don't see the new order requirement because we've got this big blanket out there, and the SyteLEAN, the CSI system just reschedules those releases. So without the blankets in place, sometimes I still need a methodology to push my future state out to my suppliers, and our supplier forecast report gives you that. Taking a look at that report real quick, and it prints to Excel, and I think I've got a copy of that coming up. Yep, there it is. So you can see that we bucketed the requirements the same way that the planning summary or master planning display buckets the requirements, or optionally you can choose to bucket them on a monthly basis. What you can see is that it shows the supplier's item and your part number, what you currently have on order, and then what the data that you see in that July, August, and September bucket, that data is looking at the planning engine, right? Querying that planning table and bringing that data back for you. That's very useful. A forecast for your suppliers. The SyteLEAN, the ability to update our remote warehouses is pretty important. Anymore, the majority of our clients are multi-site and multi-warehouse And the SyteLEAN and SyteLEAN kind of capacity to handle that remote distribution warehouse, or especially that remote manufacturing warehouse, is well, it's basically the allocation system. I know there's some new things coming with multi-warehouse manufacturing, and we're all looking forward to that. But in the meantime, I've got that simple distribution warehouse sitting out there in Houma, Louisiana, and I want to make sure that it's provisioned properly. So we can use the SyteLEAN tool to study the usage data for the warehouse and predict, again, based on a service level, what inventory we ought to keep in stock in those warehouses. So that's all we do is set up a parameter for that warehouse, run this, run the buffer data utility and calculate that data, and then we're able to push the data out to that those remote warehouses. Incidentally, it's also super important to sync up the main warehouse with the SyteLEAN data, because we want, when remember that SyteLEAN is a post processor to APS, and we want the APS engine to know that we intend to keep a supply of this item in the warehouse. So not using the not even though SyteLEAN doesn't directly use the item warehouse safety stock, the APS and MRP engines will. And so we want to make sure that they know, that APS and MRP knows what we're thinking from a buffer management standpoint. I also wanted to spend a little time on this slide talking about my average daily usage parameters. On the left-hand side of the slide, you can see that I am able to look back 1 through 13 weeks or months. So depending on your environment, I may want to look back as much as a year to calculate what my average daily usage is, or I may want to look at a more narrow time frame, maybe just the last quarter, so that when we sense your usage, we run through the material transactions, looking for the usage that I'm sure you already know to be valid, right? Any kind of order shipments or job issues or work center material issues, those things are automatically captured, and an average daily usage is calculated based on the historical record. If you choose to also use your future demand, then again, you can look at 1 week's worth, 8 weeks worth, 12 weeks worth, 12 months worth. You can look ahead to whatever extent you want, and the computer forms an opinion about the average daily usage looking forward. So I've got 2 views of the same data. How many I've used historically, how many I plan to use based on my planning system. Then those weighting factors that you see on the parameter form, those allow me to weight the calculation of the ADU. In this case, I'm weighting it more heavily on the future when there's a large disparity between the historical record and the future. I'm saying my forecast is more important to me than my historical record. I still want to consider it, but if there's a significant difference between the historical record and the forecast, then I want to make sure that I weight it towards the future. So this is important. We've had several clients, especially in automotive, that really only care about what their prime delivers to them as a forecast. They don't use the historical record much. They use almost exclusively the planning data. We have other companies that don't choose to forecast, don't have an advanced forecasting tool that makes it easy for them to simulate demand in the future. So they depend exclusively on the historical record. Both of those are easy to do with this product, and during your implementation will help you decide which one will be best for you. A couple of other features on here that I want to bring to your attention: the deduct reserved inventory. I'll get back to the expedite status in a second. The deduct reserved inventory. So let's go back to our lean thinking. We only want to signal replenishment when consumption has occurred, right? The consumption record is a hard and fast. It's true. The guy pulled the bucket forward and he emptied it. I know it's empty. I know I need to replenish that bucket. But during the pick, pack, and ship process, maybe I'm reserving inventory as soon as I print my pick list, or maybe I need a mechanism to load a container in advance of a ship date without actually doing a shipment, and I want to see the buffer down counted by that material. So that's a cool feature. If you're using inventory reservations, and they're pretty easy to use, then we can, when the reservation occurs, we can simulate, we can teach SyteLEAN to think of that as consumption, so we get a little bit of a jump on the replenishment cycle. It's a good feature. Our expedite status, and in an effort to not give you a false expedite, our expedite status is real simple to understand. If you're going to run out of parts before you come in, then you're in an expedite mode. It's that simple. And if you already have an open PO that would cover you, that would keep you from running out of those parts, then we want to make sure that we don't flag that item as an expedite. Some companies like to see that expedite status just to know they need to be proactive in the supply chain and go make sure that part does come in. Other people don't want the unnecessary signal that they need to expedite it. That spike lot percentage on the left-hand side, when we run our buffer status utility and look for spikes in the food chain, this is the default percentage we use. If you run the spike report, you can choose any spike lot that you'd like to. Basically, we're looking for those large demands that could overwhelm our buffer and create a temporary problem in the supply chain. All right. Looks like maybe I probably went over a couple of these. Obviously, I did the configure your reservations. Let's talk about putting source reference supply. If you have a large order and you source reference the supply order, either the job or the PO to that demand, we have the option to exclude those from your buffer calculations. As you know, whenever you source reference a supply to a demand in CSI, it's a hard allocation, if you will. It's a hard connection. Those two things aren't used for anything else. So in effect, there's no need for either the demand or the supply to be involved in the SyteLEAN process. So we'll give you that capability. I'm going to show you in just a moment where our auto release purchase orders is. That's a pretty cool feature. And I want to talk about the freeze buffer calculations. So under certain circumstances, and seasonality is probably the one that comes to most quickly, we want to take a snapshot of the usage in a particular period in time so that it gives us the ability to build up to that desired inventory level we'd like to have to accommodate our seasonal rush, right? So even though maybe this product line has seasonality and that product line doesn't, we need a freeze buffer calculation at the item level, and we've got it. So essentially what that does is protect an individual item or group of items from the buffer data utility recalculating those buffers when it processes. That's a pretty useful feature. If you don't have a seasonal component and you're simply running at a pretty steady pace, then there's generally not a reason to freeze buffer, except maybe on a brand new item, one where you want to set that SyteLEAN data up and then freeze it until we've accumulated some historical information. On the SyteLEAN parameters again, when the buffer status utility calculates, we have the ability to, for a group of orders, go ahead and instead of creating PLNs that you see in your workbench, we can go ahead and create purchase orders in the ERP. When you couple this with a supply chain collaboration tool, SourceDay or SyteLEAN's vendor portal, that's starting to get to be a pretty cool way to automate the repetitive, frequent, just those activities that are required on a daily basis for these repetitive items. Obviously, we start using SyteLEAN without this auto creation mode until our purchasing team can build confidence in the algorithms. And then if we do choose to use SyteLEAN to automatically generate POs, that's available to us on a planner code by planner code basis. Also want to mention one more feature. We report excess in SyteLEAN, and excess is the number one cause of waste in a lean environment. In manufacturing is overproduction, and I think overprocurement belongs in there too. Really, it's just any overage of supply. But invariably, you've got a vendor who won't push less than 500 pounds through the extruder, or won't mill less than this many tons of material for you, and those multiples cause your new order to actually be larger than is suggested by the SyteLEAN product. So we don't want to tag you for those as being excess, because you've negotiated with the supplier in such a way that you're satisfied. It's a mutually beneficial arrangement, and we want to make sure that we can acknowledge that that's not a excess condition. That's what that add order multiple to the excess range does for you. Taking a look at this, I think for those of you that are using the MRP system, the item max is not a available field to you. Item max is typically just a APS field. It's super important. We've got a lot of companies that build large equipment, and they build them one at a time, and they don't want an order for 3 or an order for 5. They want an order for 1. And the standard Cloud Suite product enforces the order max or item max only on manufactured items. That's great, but you may also have an environment where you want to enforce it on purchased items, and SyteLEAN lets you use it on either. So it's almost my last slide here, so we're going to have plenty of time to ask questions. The game, what we're up against with SyteLEAN, is defining a set of rules generally implemented using strategic lead times, day supply, service levels, to define the predictable average inventory and the tactical Kanban replenishment functionality. And once those rules are set, we want to honor those rules. We want the purchasing system and the manufacturing system to both trigger replenishment coming from that set of rules. So it's a great little It's a great little process. Certainly won't replace MRP or APS for most companies. Certainly the build to order guys need that customer order signal. Although a lot of my build to order companies have a build to stock component supporting those build to order end items. I think you understand that, right? We're not gonna assemble that aircraft until we know whether it's going to be a dual seater or a single seater. But boy, we can work on all the lower level components in the fuselage and wings before to mitigate lead time issues, so that we can keep our lead time from blowing up on us. It's pretty simple to implement. Generally, the implementation services are a couple of days, as opposed to think back to what it took you to implement either MRP or APS. Of course, we're leveraging a lot of that knowledge. That's one of the reasons why we're able to do this pretty quickly.